Hi, my name is Alicia Lovelace, and you've come live from my living room here in Barstow, California. Today we're going to talk about some statistics. I hope you enjoy my presentation. Today we're going to talk about the null hypothesis versus the alternative hypothesis, a one-tailed test versus a two-tailed test, and how do we know when to use what? What is a type 1 error? How do we determine the test statistic and p-value? And how do we determine the critical value and draw conclusions? First, we're going to talk about the null hypothesis. A null hypothesis is a type of hypothesis that is used in statistics testing that propose no statistical significance exists in a set of given observations. The null hypothesis attempts to show that no variation exists between variables, or that a single variable is no different than its mean. It is presumed to be true until statistical evidence nullifies it for an alternative hypothesis. An alternative hypothesis in statistical testing is formulated in direct opposition to the null hypothesis. In hypothesis testing, an alternative hypothesis is a statement in which the researcher themselves are testing. This statement is true from the researcher's point of view and must ultimately prove to reject the null and replace it with an alternate hypothesis. The null hypothesis versus the alternative hypothesis. The null hypothesis is the initial statistical claim that the population mean is equivalent to the claimed. For example, assume that the average time to cook a specific brand of pasta is 12 minutes. Therefore, the null hypothesis would be stated as the population mean is equal to 12 minutes. Conversely, the alternative hypothesis is the hypothesis that is accepted if the null hypothesis is rejected. Null is the accepted hypothesis, or the truth. The alternative hypothesis is the opposite, or the non-truth. One-tailed test versus a two-tailed test. A one-tailed test allows you to determine if one mean is greater or less than another mean, but it does not let you do both. A direction must be chosen prior to testing. It should only be used when you are not worried about missing an effect on an untested direction. And here is a graph of a one-tailed test. It's got a couple of pros and cons. And the opposite test of this one is going to be the two-tailed test. And the two-tailed test allows you to determine if two means are different from one another. A direction in this one does not have to be specified prior to testing, and a two-tailed test will take into account the possibility of both positive and negative effects. And here is a two-tailed test with some pros and cons. A one-tailed test versus a two-tailed test. How do we know when to use it? Simple. It's based on the language. A one-tailed test is if a hypothesis test uses the words more than, greater than, fewer, or less than. These specific words indicate a one-tailed test. The language itself tells you which direction you are going to be looking at. Less, fewer is going to be a left tail. More or greater is going to be a right. A two-tailed test is used if the hypothesis test uses words such as equal to or is not equal to. Then you're going to be looking at the two end results. Type 1 error is when you reject the null hypothesis, but it's actually the truth. It's also called a false positive because it forces the researcher to make a positive statement that something odd is happening when in fact nothing is happening at all except some chance. Examples are false positive pregnancy test when you're not pregnant, and a positive drug screen when there's no drug usage. How do we determine the test statistic and p-value? Well, the test statistic is a random variable either inside or outside the hypothesis test area, which is the population. Placement of this test statistic depends on what your researcher is trying to do. If you're trying to reject the null hypothesis area, or you're going to fail to reject the null hypothesis area. This test statistic here on this graph is going to reject the null hypothesis because it is outside of the testing area. What is a p-value? A p-value is also a probability value. It measures the strength of evidence in support of the null hypothesis. It's found by either using a z-test or a t-test, depending on what information you are giving. Standard deviation and trial size are factors of which formula to use. Here is a nifty little guide that tells you what to do if you have a standard deviation or not, and about the sample size, if it's too small or too large, if you're supposed to use a z or a t-score. What is a critical value? Well, a critical value is a number on the borderline separating sample statistics that are likely to occur far from those that are unlikely. The symbol alpha is used to denote the significance level of the test. And it's usually a small number that translates to a percentage. So 0.01 translates to 1%, 0.05 is 5%, 0.10 is 10%. The most commonly used critical value is 0.05. Right there is a little picture. Now, how do we draw a conclusion? Well, we draw the conclusion after we calculate the p-value, either through a z or a t-score. A small p-value, typically less than 0.05, indicates strong evidence against the null hypothesis, so we can reject the null hypothesis. A large p-value, greater than 0.05, indicates weak evidence against the null hypothesis, so you can fail to reject the null hypothesis. P-values very close to the cutoff of 0.05 are considered to be marginal, and they could go either way. There's a couple diagrams real quick of what a z-score and a t-score formula look like. And that is the end of my presentation. I hope you guys really enjoyed it. Thank you so much and have a great night.